Ladies and gentlemen.
So today we're going to talk about polynomial identities. We're kind of going backwards. Right, we need to cover three now, as we're starting to get ourselves into the point where we're starting to get ready to factor, which means we're ready to find zeros, which means we're ready to graph. So we're getting kind of closer and closer to kind of the end goal that we had when we started polynomials, which was essentially being able to graph them. Okay, tomorrow we'll be able to graph them. We've got these identities that we have to talk about. Today we've got 4 different identities. We'll concentrate on 3 of them and then 1. So we want to use the identities to multiply and factor polynomials. More or less, we're going to factor polynomials today. We're not really going to multiply very much. So what is an identity? An identity is simply a mathematical statement that equates 2 polynomial expressions. So a mathematical statement that equates 2 polynomial expressions is an identity. It essentially says that if I have an expression, this is what it equals. And you can, it's kind of a way to think of a shortcut to do things. Instead of foiling things out, we can use shortcuts. We can use its identity to do it. Right? Instead of factoring some things using different methods, we can use shortcuts. And those are the identities. Those are the identities that we're going to talk about today. We've got 4 of them that we're going to talk about. First one's not new. First one we talked about earlier in the year. We've talked about differences of squares when we were factoring quadratics. Difference of squares simply says that a squared minus b squared is equal to a plus b times a minus b. It's just the shortcut way of factoring a squared minus b squared. Depending on what you have, you could use the x method to do this as well. Just keep in mind that where does the a and the b come from? The a value, that comes from the square root of a squared, and your b value comes from the square root of b squared. So the square root of a squared is a, obviously. The square root of b squared is b, obviously. So that's where your a's and b's come from. And then it's just a plus b and a minus b. If you put a minus b and a plus b, that's fine. It's the same thing. So if we have something like x squared minus 9. And again, we did this one. But so my a value is just going to be the square root of x squared. Well, square root of x squared is just x. So a is equal to x. The b value is going to equal the square root of 9. So then b is equal to 3. So that's where we get that x plus 3 and x minus 3. And obviously, you get used to these pretty quickly. And you don't need to write all of that down. It's kind of whatever. I just wanted to show you where it was from. But things you have to keep in mind is you want those to be both perfect squares. So you want both of those terms to be perfect squares. And they have to be subtracted from each other. If they're added, this does not work. There's no such thing as the sum of squares. Okay? That simply doesn't work. So that's our first identity. And again, the identity is just the a squared minus b squared. It's what it equals. Okay, so that's the difference of squares. Second one, it's called the square of the sum. And this is kind of going the other direction. We're taking this from a plus b squared, where we got the quantity a plus b squared, and kind of essentially just shortcutting it out to FOIL it, if you FOILed it. If you just did a times b times a plus b times a plus b, and FOILed it, this is your end result. It's just a shortcut. So anytime you have the square of a sum, it's a squared plus 2 times ab plus b squared. And it's really as simple as that. Okay, you just square whatever your a value is sitting there, multiply the a and the b together, and then b squared. So an example of this one, and I'm not going to break this one down so much, but if we have x plus 6, let's make this a little bit bigger so you guys can see it a little bit better. If we'd have x plus 6 squared, well, it's a squared. My a value is x, so it's x squared. Plus 2 times a times b. A is x, b is 6. 2 times 6 times x is 12x plus 36. And you're done. Okay. Then again, this one's just the sum. That goes kind of the other direction. If we were going to factor this, if we were going to go from the quadratic back to this direction, you just have to notice that this, we've talked about it a little bit, the square root of that is 36 and is 6, and then times 2 is 12, so it would work. But more than likely, if you see something like that, quadratic, you're just going to do the x method to factor it. So those are the first two. Next ones now are going to be new. So the first ones we call the difference of cubes. So difference obviously means to subtract. So now we want to be able to find the difference of cubes. So a cubed minus b cubed, we get the quantity a minus b times the quantity a squared plus ab plus b squared. And again, the a and the b, but now instead of a being the square root of a squared, a is just the cubed root of a cubed, and b is the cubed root of b cubed. Okay, so you're just doing a cubed root instead. So we're really looking for perfect cubes when we're doing this. So if we have something like 8m cubed minus 27, what I'm looking for when I'm looking for differences of cubes is I'm looking for perfect cubes. So a number multiplied by itself 3 times, that gives us that number. And then making sure they're subtracted. Cubed root of 8 is 2. 2 times 2 times 2 is 8. Cubed root of m cubed is m. So that's where the 2m comes from. I'm looking for the minus sign. Obviously it's a difference, so it has to be minus. And then I'm making sure that that b value is a perfect cube as well. 27 is 3 times 3 times 3. So my b value is 3. So that's where the 2m minus 3 comes from. Okay, that has to be a minus sign and that has to be a minus sign. That doesn't change ever in a difference of cubes. Same thing with the rest of the signs. Now, the next part says a squared. So my a is the first term, so I just square that whole thing. 2 squared is 4m, so that's 4m squared. This is a plus sign. It doesn't matter what's going on in here. You just take the a and the b times each other. Don't worry about the symbol. That has to be a plus. 2 times 3 is 6. That's where the 6m comes from. And then 3 squared is 9. Okay. And you can kind of check these out, at least the first part of them, to make sure that you're in the right space. You take 2m times 4m. That gives us our 8m cubed. Negative 3 times 9 is negative 27. So it looks like I have the plus and minus signs in the right spots. And that becomes the biggest part with this, is being able to make sure that you get the pluses and the minuses in the right spot. Okay? And just keep in mind that we've got a minus 27, so when I multiply these minuses together, these last terms together, I mean, they have to be negative 27. They have to be negative. And a negative times the positive is going to give us a negative. Okay? So that's the difference of cubes. Now we're going to use this to eventually find zeros. So I know that one of my zeros is going to be at 3/2. So my graph has to cross at 3/2, the x-axis. I also know that it's going to cross maybe here too, depending on what this is. But obviously, that's not going to factor any further. So the only way we have to solve this is by the quadratic formula, which you're going to have to do eventually. But that's not today. Okay? So that's the difference of cubes. So unlike differences of squares not having the sum of squares, there is the sum of cubes. Okay, and this works out as well. So a cubed plus b cubed. The only thing that changes in here are the signs. Okay, the a's and the b's, the a squareds, a b's, and b squareds, those stay the same. The only thing that changes is your sign. So now this is a plus b, where before it was a minus b. And now it's a squared minus ab plus b squared. Okay, so again, if we look at the last terms then, we've got a positive and a positive. We're going to end up with a positive, and we're good to go. Okay, so you just have to remember which one's a negative and which one's a positive. And it just switches between the last term is always positive, squaring it, so that's always positive. You just have to figure out the first two terms, which one's positive and which one's negative. And again, just think about the last one. The last one for the difference has to be negative. The last one for the sum has to be positive. So just make sure you've got your positives sitting in there. So a sum of cube 1 looks something like this. A cubed plus 64b cubed. Cubed root of a cubed is a. Cubed root of 64b cubed is 4b. So that's our a plus 4b. And then if you have to write the a and the b down, I'll do that when I do the first example here in a second. You can, some of you would just be able to get away with, it's that squared, this times this, and then that squared. You just got to get your signs right. Okay. So those are the 4 identities that we have and that we're going to work with. Vast majority of our time today, most of our time today, all of our time today, is just going to be spent with the difference of squares, the difference of cubes, and the sum of cubes. The sum of the squares, that'll be later. We're not going to work with that one too much today, but you just needed to know that it was an identity. There's me running. So if we look at some examples. So the first one we have is 4m to the 4th minus 25n to the 6th. Michigan glasses. That was just last week. It was so cold that day. I had to have 2 hats on. I actually have a hat underneath them. So if we have 9m to the 4th minus 27n to the 6th, here's kind of, we got to figure out which one it is, if it's one of them at all. Look at the numbers. Don't look at the variables. If you look at the variables, it can mess you up. Okay, look at the numbers. And if the numbers are perfect squares, 9's a perfect square. 25 is a perfect square. I'm subtracting. Second thing you need to look for if you're looking at exponents is make sure that your exponents are even. If they're even, we're good to go. If they're odd, they're not. Okay? So when we do this, so we've got a difference of squares going on here. So my a value is going to be the square root of 9m to the 4th. That's going to give me my a value. So my a value, the square root of 9 is 3. The square root of m to the 4th is m squared. So there's my a value. My b value is going to be the square root of 25n to the 6th. Square root of 25 is 5. The square root of n to the 6th is n to the 3rd. When you're doing radicals, you got a variable, just divide your exponent by whatever root you're taking. Okay, so now I've got my a and my b values. So now this is a plus b. So 3m squared minus, or plus, it doesn't matter which one you do, a minus b times a plus b. There's your solution. And you're done. Okay. You could sometimes end up where, oh no, this could have to be possibly, maybe, a perfect square as well, and you might have to break down something in here. In this case, not because you don't, but because I've got funny numbers. But that's done. Okay, so that's an example of the difference of squares. Now, this part over here, this part here, this is completely optional. I mean, some of you need to do that, and if you need to do that to remember what your A and B values are, perfect. There's nothing wrong with that. If you can get by without doing that, which probably most of you can, don't put it in there. It's just a way for me to kind of teach it to you, to show you what's going on. So the next one, I've got x cubed minus 216. So right away you should be thinking, well, the x cubed is probably a cube. We're subtracting, and 216. Is 216 a perfect cube? We know perfect squares pretty well. Perfect cubes we don't know very well. If you use your calculator to do perfect cubes, the way you do this on your calculator, if you have the TI-31, the way you do it on your calculator is you have to hit your root first. So you have to hit 3 first. And then hit second, and then the caret. I call it a caret. This thing looks like an arrow. So on your calculator right now, you should see something like 3, and then like this. And now put 216 in there. That gives you the cubed root of 216 on your calculator, which is 6. Okay, so the cubed root of 216 is 6. So we're looking at difference of cubes. So difference of cubes, just to remind you, it's a minus b times a squared plus ab plus b squared. These should be things that you get stuck in your brain. If it doesn't get stuck in your brain, look to your right. They're over there. Okay, they're on the cupboard already. They're not going to be taken down. So they are sitting there for you to use. Not a bad thing to have in your brain, though. So my a value, cubed root of x cubed is just x minus 6. My a value is x, so x squared. It's got to be a plus. 6 times x is 6x. Plus 6 squared is 36. That's our solution to x cubed minus 216. Again, today we're just factoring it. Tomorrow, this is going to be set equal to 0. And we're going to have to figure out how to graph it. You're not going to have to factor tomorrow. Tomorrow, you're actually just going to get that part of it. And we're going to graph it. Eventually, we'll get all this put together. Taking forever to get it put together, but we're getting there. Questions with that one? I needed something to use to slide down so you couldn't see all the problems. So we've got x cubed plus 125. Okay, so I know x cubed is obviously a perfect cube. 125, 5 times 5 times 5. Now we're adding. So I look over there. I'm not going to write it down this time. So it's a plus b. So my a value, the cubed root of x cubed, is x. It's plus this time. Cubed root of 125 is 5. And now it's a squared, so x squared minus a times b, so 5x plus b squared. 5 times 5 is 25. And there you go. You're done. And remember, you can always check these out to make sure they work. If you want to make sure you're right, distribute it back out or do the box method to see if you're right or not. Okay? Next one. So let's start getting a little bit harder. So you got 27x to the 5th plus x squared. So 27 is a perfect cube. 3 times 3 times 3. X to the 5th isn't, and neither is x squared. Uh-oh. Okay, so I can't do, it's a sum, so I can't do sum of cubes. Sum of squares doesn't work. 27 is not a square. What do I do? What do I have to do with this one? What's the first rule of factoring? GCF. What's the greatest common factor in those terms? X squared. So we're going to take out an x squared. Maybe. So I take out an x squared. If I take out an x squared, that leaves me with 27x cubed plus 1. 27's a perfect cube. X cubed is a perfect cube. I've got a plus sign. 1's 1 times 1 times 1. So it works. So this is going to be x squared. Square root of 27, cubed root of 27, sorry. Cubed root of 27 is 3. Cubed root of x cubed is x. Plus the cubed root of 1 is 1. My a value is 3x. So the quantity 3x, that's 9x squared. Minus a times b, so 3x. Plus 1 cubed, which is just 1. There's your solution. So GCF. Always, always, always think GCF first, especially when you start looking at it and nothing makes sense. Now, you don't have perfect cubes sitting there. If you don't have perfect cubes sitting there, that can then lead to some issues. Okay. Next one. 25x squared minus 100. This is kind of one of those that there's really two ways to do this one. Okay, because 25 and 100 are both perfect squares, you can kind of disregard the rule of taking out the GCF, and you would be fine. But don't. Take out GCF. Okay? You get the same answer eventually if you're finding the zeros. You'd get the same answers. But take out a GCF first if you can. And the nice thing about when you take the GCF out of this one, and why I would do this, our GCF is 25. So if I take 25 out of there, I'm left with x squared minus 4. I still have a difference of squares. X squared is a perfect square. 4 is a perfect square. So now the solution to this becomes 25. The square root of x squared is x, minus the square root of 4 is 2. And then x plus 2. Okay. Where, if you had 5x minus 10, it's 5x plus 10. If I asked you to find the zeros, what makes this 0 is 2. What makes this 0 negative 2? What makes 5x minus 10? That's just 2. So you get the same solutions no matter what you end up doing, but it's always a good idea to get used to taking out that GCF. Now, if I would have taken out the GCF and the results in here wouldn't have been perfect squares, I would have just done this. Right? I don't know if that ever happened, but it could, I guess. All right, let's make them more fun. I think we got 2 left. So we've got 648x plus 1,029x to the 4th. So GCF first, easy enough. Variable is x. So we can take an x out. So that's easy enough. So now the next question I'm asking myself is 648 a perfect square? The answer is no. It's not a perfect square. So it's not a perfect square. So just taking that x out, it's not going to help a lot. So now I got to start looking for numbers to see if the numbers have a common factor. And with any luck, the number that's a common factor will result in these being perfect cubes. Okay, we got to find one. I don't remember what it is. GCF for 648 or a common factor for 648 and 1029. 3 works. 3 does work. Anybody know how I know 3 works? Divisibility rule. If you add them all up and they're divisible, if you add them all up and that's divisible by 3, the number's divisible by 3.
Let's see that.
So 6, 4, and 8 is 18. 18 divided by 3 is 6. That works. So 648 divided by 3, what's that? What is it? 216. Is 216 a perfect cube? It is, right? Okay, so if I take 3x out of there, that gives me 216 plus 1029 divided by 3. 300 and... What is it? 43? 343x cubed. 343 is a perfect cube. 7? No? Yeah? No? Is 343 a perfect cube? 7? Okay, so it works. Now, it's backwards, right? I mean, compared to what we usually see, it's kind of backwards. Listen, so you know that. Could I switch this around? Yes. We could switch this around if you want to. You could make this 343x cubed plus 216. And you can do that because you're just rewriting the same thing. And that'd be more of a way that you're used to seeing it. But you don't have to. Hey, we can leave this as 3x times. The cubed root of 216 we said was 6 plus 7x times 6 squared is 36. 7 times 6 is 42, so minus 42x plus 49x squared. That's our solution to this. Okay? And we can flip it around, and you could have put 3x times 7x minus 6, 49 minus 42x plus 36. It's the same thing, but you don't have to. Okay? Questions with that one? All right, last one that I want you, and I'm just going to let you guys work on this one. I'm going to switch this. I'm going to make that a minus. Go ahead and factor that. GCF is 3y. I think so. So that's 343x cubed minus 8y cubed. Okay, quick side note. I said up here with the 216 plus 343x cubed, you could switch that one around and it would be okay. Can you do that with this one? No, don't do that with this one. Do not make it negative 8y cubed plus. Don't do that. Okay, leave it as difference cubes. Okay, don't factor out a negative so you can, just leave it like that. So we've got 3y. 343, I think we said was 7. So that's 7x. It's minus, so this is going to be a minus. 2y. 49x squared plus 14xy plus 4y squared. We do okay? Any questions with polynomial identities? And again, remember where this is leading. This is all kind of leading back to us being able to graph these things and being able to factor these things and do all of those different types of things.